quantum computers always need cryogenic temperatures and vacuums and other measures to prevent qubits from being disturbed by noise?
It depends on which paradigm ends up taking over, right? Right now, we're in a state where it feels similar to where we were with Blu-ray discs versus high definition discs. There was an option of which one should I start putting money into, and one's probably going to take over, and then I won't be able to use my DVD collection if I bought the wrong one. Um, but right, there's several different types of technologies to develop quantum computers, and that's because there's a bunch of different ways to make a qubit, right? This fundamental bit of a quantum computer, the bit that behaves quantum mechanically. If you're working with uh, physical bits, right? If you're working with ions or atoms, you're gonna need to lower their temperature to be able to work quantum mechanically and to make sure that nothing hits them so that they, spontaneously become non-quantum mechanical, right? Air, if it interacts with a quantum particle, will mess up its quantum state. There are different paradigms like photons. If you're just working with light, which is also a quantum mechanical particle, if you're working with light, you don't have to worry about those low temperatures, right? That technology is still being developed and isn't at the stage that IBM's technology is with their superconducting qubits, but it is a technology being investigated for that very reason. You could eventually have systems that don't need these big old doers, giant mission, systems.
Right. Now, my follow-on was if you do have all the need for cryogenic temperatures, wouldn't that make them rather expensive and rather uncommon and maybe unsuited for laptops, desktops, and my handheld quantum computer?
Yeah, certainly. I can't imagine having one of these, big old doers and quantum mechanical systems in my office anytime soon. Um, it's expensive, but it's not difficult to actually, put one of these things together and maintain one, right? So, you need these giant doers, you need big old magnets. Actually, it's part of it to get to these ultra low temperatures. Right now, the way quantum computing is being deployed is that because it's so expensive to have one on premises on site, they're being cloud deployed the same way that high powered computing is being deployed, right? You buy some time on Amazon Web Services to use their high powered computer, and the same thing you can do with their quantum computer now. You can buy some time right now and say, I'm going to send this program to their quantum computer. Um, so that's the way the industry is heading. And right, if another paradigm doesn't come out that has, that doesn't need this ultra low temperature, we're probably going to stay in this cloud deployed state. There might be a state or a couple of use cases where, especially I could see financial companies wanting one of these machines on site so that their data packets can get sent back and retrieved very quickly. Anybody who's very sensitive to the time of their calculations will probably want one of these on site, and they probably could afford it too, because they're not cheap systems. But there will be use cases where certain companies will have quantum computers on premises.
Well, that sort of brings up the question. You talked about cost. What do you think a quantum computer will cost?
Oh gosh, you can buy a quantum computer right now. I think D-Wave you can call them up and pay I don't know how many millions of dollars it's going to cost, 10, 20 million, but you can buy one.
Uh, you might be able to buy one. Put on your prediction hat here. Will there ever be small, portable, relatively inexpensive battery-powered quantum computing? And are they
I
half a
mean,
century away or more, or is
I've learned with technology, never say never, right? I can definitely
right,
see a future, and people are investing big dollars into making these quantum technologies that don't need, right, these cold temperatures.
right?
Because that is a technology people want. There's definitely business value in that. When there's business value, you're going to see you both, scientific and industry drive to get there. So I don't know when we'll see that. I'll certainly be excited when I get to quantum computing or a bit of that on my phone. That'll be a fun time. But for right now, in the near term, it's going to be cloud deployed hybrid computing.
And again, I guess I'm beating this horse to death. Any idea when QCs will be in commercial production, and any clue as to what they might cost? Again, you said $10 million. That pretty much keeps it out of my computing room.
I mean, the same thing could have been said with computers when they were first being developed, right? There were giant
Absolutely.
machines that took up a whole room that was impractical to have on premises. And
I believe someone once said, nobody will ever need a computer in their house. You know,
exactly. So we're having the same discussion today, and I'm sure in 20 years we'll look back at this and we'll laugh and say how wrong we were, and we'll be using quantum computing on our phone, right? But it's technology moves at an incredible rate. I mean, my daughters don't even know what a CD player is, right?
okay, all right. Any other comments or thoughts on quantum computing at this stage? Do we have a father or a mother of quantum computing yet?
Well, father and mother of quantum computing. That's a good question. It's a community, right? It takes a village. So while there may have been a
Okay,
father
all
or
right.
mother, it's taking a village to build that community up.